Hello, alright, we're going to get straight into this week. A bit of a later video today. I mean, it's still 8 days before the assignment's due, so it's fine. This is the topics, pretty easy stuff. This is kind of like a week where we're kind of in limbo because after this week, we're getting to the hardest topics of like the first year. Um, Definitely the hardest part. But this week of the learning pack's fine. I mean, it's really not that hard. Um, but be ready to don't be put off by this week being kind of like medium difficulty because it's getting a lot harder over the next 4 weeks after. All right, it's time to do the assignment. Just a note that if you want a better explanation for section A or most of section A, I have another video on my channel already with this exact paper on it. I'll probably link in the description. But anyway, let's get straight into it with this assignment. So, first question, we have this integral here. I'm sure no one will struggle with this. Just remember the plus c, and then you set it equal to 8, and sub your limits in, the new limits that it created, and then solve. You get this. Next, you got a linear model, so you can say that these are just points, and you can use you can find the gradient, use straight line formula, however you want to find your straight line formula, however you like to do it. And then you get your model, and then they love these 1 mark explain questions in the papers. So oh, this is one of the actual values, so does this support the model that you create? And it so when you substitute this value into the model, or because it says when it was planted, that means when t equals 0, it's 142 centimeters, which means that it is pretty close to the model. The model's pretty accurate because it's pretty close to what it actually is. Anyway, so differentiation, this is just some year 1 differentiation stuff. Yeah, none of this fancy stuff, just differentiate. I actually should have done dy by dx equals here, and then set it greater than 0, solve, blah, blah, blah. Yeah. Alright, here we got some GCSE trig. You just do area of triangle rule. I mean, it tells you the area, so it's pretty obvious what you're supposed to do, and you have the area of a triangle set up. Get x is 2 root 3, and then find the exact length of BC, where you just use cosine rule. I didn't actually write it out, but you just use cosine rule. Next, we have this question. Sketching. I mean, yeah, I drew the line from the next question on as well, but you have to state this equation. And we want to show that this is this when they intersect. We want to show that this equation works. So what do you do when curves intersect? You set them equal to each other. So get that, rearrange. You get your equation. L is tangent. Whenever you see a question that's find the value of something for which it's a tangent, it just means it's one solution. So you can say the discriminant equals 0, and solve for k. So it's plus or minus root 2. Next, we have this question. As you might know from the last assignment, I figured out a new method for differentiating stuff that's reciprocal from first principles, where so you get your little first principle set up here, and you multiply by you always have 1 over something, 1 over something plus h minus 1 over something whenever you have something like this. So you just multiply the thing plus h and also multiply the thing. So here we have x plus h cubed and x cubed. Multiply both sides of the fraction by both of those things, and you end up with this. And then what you can do with this, you can expand this. The x cubed terms cancel out, and what actually happens here is that I've done a few things here. So if we're looking at this line, we expand. The way I went from this line to this line, so if you were to separate the minus h cubed term, so these are now 2 separate fractions. The 3x squared h minus 3xh squared are on this fraction, and then minus h cubed is on the other fraction. They both have the same denominator. If you were to put a 0 into this, the h cubed would turn into 0, but the denominator would actually turn into... It wouldn't be 0 over 0, because if it was 0 over 0, we can't do it yet, which means we'd have to keep solving. But it's 0 over x to the 6, because all these terms will cancel, but the x cubed times x cubed won't cancel, which means that it becomes 0 over x to the 6, which means it just turns into 0. And then what you can do here is, now this h cubed is gone, you can cancel one of the x's from the denominator. And I've done the exact same here with the minus 3h squared, so took it away from the fraction, substituted 0 in, and then it completely cancels out from the expression, and then you can cancel this x from this x, and you just get this. And I've done the exact same thing here. So this is kind of a visualization of what I've done. So you get -3 over this, then you expand, and you see that all these terms cancel except the x to the 4. So when you substitute h equals 0 in, it becomes -3 of x to the 4, which is the correct answer. There's probably a lot of other ways you could do this, but it's just nice to know that every single time you have a reciprocal, you can do this and it will work. Because a lot of the time, when they give you harder first principle questions, you don't really know what you're doing. So you kind of keep going until it works. Right, anyway, next we have this was like I like 12 of the questions out of 15 on section A or on the AS paper that I mentioned earlier. So this one wasn't. So unfortunately, there's not, in my other video, there's not another explanation. But anyway, next question. Well, we want to know, this is just a random model they've given us. These are, in the paper, these were all like 1-2 mark questions. So, yeah, I mean, there's not much work for any of them, so it makes sense. This is just saying when it's been 1 year, so n equals 1, substitute, you get your answer. Maximum total mass, I mean, whatever n is, you're taking away some value of n, or you're taking away some processed value of n, which means that the maximum is just when this big thing here is 0, so it's just 1,200. And then we're saying in 2023 is, because this model gives us, like, if we put n equals 5 in, it would give us from 1st January to 2019 to 1st January 2024. So if we want just 2023, we do 1st of January 2024 minus 1st of January 2023. Which means you just do n equals 5 minus n equals 4, and then that gives you your answer. And then the limitation on the values of n, well, it's just saying that if n was above 20, yeah, if n was above 20, then it would kind of mess up because, what? No, this doesn't even make any, wait, sorry. N can't be, yeah, n can't be above 20 because otherwise, oh, yeah, sorry. If n became too big, then, yeah, if n became too big, then, I don't know why I said above 20, because it would work if it was above 20, but, no, this makes sense. So sorry, I don't know how I figured it out so fast when I was doing it, but so because this is some sort of like quadratic, this is like a quadratic basically. So you can see, because there's an n, there'll be an n squared term, there'll be an n term, and there's a constant term. So if you think about this, it's a negative quadratic since there's a negative here and there's an n. So what's going to happen? The maximum is 1,200, but after 1,200, which is after n is 20, the total mass of tin is going to be decreasing, which doesn't make any sense because you can't. That we're basically saying, oh, in 2024 we're going to have 1,200 total, and in 2025 we'll have 1,100. So we would have mined minus 100 tin, which doesn't make sense. Right, sorry, I don't know why that took so long to get out. So circle question, a bit of a break. You can see if they just ask for the sensor, you can just kind of figure it out without actually having to complete the square by just halving and like switching the signs. But they did ask for the radius, so I had to complete the square to get that. Especially because the radius wasn't it wasn't a perfect square, r squared. And now it's asking where x equals k as a constant is a tangent, like we saw on the previous question. So it's easier to not put into the original version, not the completed square form. So you just substitute k into all the x's, and then you do the discriminant equals 0, and then you solve. Yeah. Right, this is another pretty simple question. Show that x minus 4 is a factor. I always do this. You should remember, always actually show that it's a factor and always write a conclusion, like therefore it is a factor. I'm just doing this for the sake of not wanting to write that every single time in an assignment. Show that it has two roots. Well, usually, I mean, if you don't know what to do here, like, what does it always ask you after, like, you have a factor? It just tells you, it usually asks you to divide. So if you divide, you can prove there's two solutions by just finding the two solutions. So these last two questions are like 1 or 2 markers, just like kind of logic-based questions. So it's asking the number of roots to this equation. Well, this is just this, but being moved back down by 2. So this equation is just this equation, but moved down by 2. And if you look at the graph, because they give you the graph, it will go under the x-axis, which means that it will have an extra root, so there'll be 3 total roots. And then for this question, it's asking you what values of k does f of x plus k pass through the origin? Well, the root is at 3/2, so f of x minus 3/2. So no, sorry, this root was at 4. So f of x plus 4 will bring it left 4, which means it will bring it through the origin. Same with this one. So if it's f of x minus 3/2, it brings it right 3/2, which means it goes through the origin. Yeah, that's kind of another just the kind of logic-based question. For this question, I mean, because maybe in the context of this assignment, you might have like been able to try a lot of different things, but in the context of the AS paper that this was in, you're only supposed to know the 2 original trig identities, so there's not much you can really try here. So I just turned it into causes, and you can just assume that it's gonna, because we're saying it turns into this, and we know that the denominator is this, so you don't actually have to factorize it yourself. You can just use the question to factorize it for you, and then it will cancel and you get the answer. Obviously you can check and do it yourself, but it's just like little tricks like that can help. And then they always do this where they make you solve it, like they make you use your previously obtained result and then solve, and then it becomes this, and you just solve for your values. It should be x's, not thetas, actually. That probably would have lost me a mark. Right, next question. This was like a 7-mark question on the paper that it was on. But so it's just asking you to find the area under this curve, and then it's a turning point. So firstly, you find the turning point, differentiate, solve, blah blah blah. You find the turning. You see you could do double derivative to find that it's a minimum, but you can just see from the graph that, and also from the fact that it's a positive cubic, that the more positive, like the higher one, is going to be the one that we want, because there's 2 stationary points, and we want the one that's further to the right, which means that it's x equals 4, not 5/3. And then now we know our upper bound of our integration, so we can just integrate, find the area, and that will give us our answer that it's asking for. Alright, so we have some more modelling stuff here now. Yeah, so firstly, initial value, t is 0, which means that the e bit becomes 1, so it's just 15,700 plus 2,300. Given that the model predicts it's decreasing at this rate, whenever you see rate in a model question or at all, you think about differentiation. So you just differentiate, and you know the rate is decreasing at a rate of 500 means it's negative 500. And then you substitute big T into T, because that's what it asks you to do, and then that's your result. Then for part 2 of this question, you just find T by you solving as like an exponential equation with ln. And for some reason it makes you convert it into years and months, which is kind of annoying. But yeah, you can just see that this is years here and then convert decimals into months. Saying that this is a similar thing to the other model question, so it's saying it does not fall below this amount of money. Well, this entire expression is just all it's doing is decreasing the model, because there's a negative here. So this so the maximum is just 2,300, because if this entire thing is 0, which is the maximum that it can be, it will just cancel and give you 2,300. But like if it wasn't 0, it would be a negative number, which means it decreases the value. And then limitation, there could be like a million things you could say here. So yeah, but I just said that there could be other factors. You have to see the context of the model, so it's a value of a car, so you could just say that other factors could affect it. And more instantaneous things can affect it, because obviously a model cannot predict that. Yeah. All right, proof question. exhaustion. We just saw this on tracking test 4. Yeah, case 1, n is odd, blah, 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 blah. And then, actually, no, I'm not just gonna blah, blah, blah this, because it was actually a bit of a weird proof question, because you could, I think, it might have wanted you to do double, like, exhaustion again here, but I just said that, so you get here, you get 4m squared plus m plus 3, and you just say that, even, so 4 times anything plus 3 cannot be a multiple of 8, so even if m squared plus m is odd, then obviously it's not going to be a multiple of 8 because it's going to be an odd number, or it's not going to be a multiple of 8 at all, because it's going to be a multiple of 4 plus 3. And then even if it is a multiple, even if m squared plus m is even, which means that 4 times m squared plus m would also be a multiple of 8, a multiple of 8 plus 3 is never a multiple of 8, which means that this case isn't true. Then for the even case, this one's a bit weirder. Then we're saying that we have this here. We say if k squared is odd, then 4k squared is even and a multiple of 4, but not a multiple of 8. Because I don't really know, because it just kind of says proof in the answer, so I don't know if it wants you to do like double exhaustion here. But then for k, so we don't actually look at when k is odd, we just look at when k squared is odd, because there could be different cases. But I mean, bottom line is just saying that then, well, obviously if k squared is odd, then 4k squared must be even. It also would not be a multiple of 8, because otherwise k squared would have to be even. And obviously a multiple of 4 plus 2 is not a multiple of 8. And then if k squared is even, then it would be a multiple of 4 or a multiple of 8 plus 2, which means that it can't be a multiple of 8, because it would either be a multiple of 6 or a multiple of 10. But, I mean, like, it's just the hard part is kind of just explain this, because you can kind of see from this that this cannot be a multiple of 8. But you kind of just have to explain that. But yeah. So when I actually did this paper for the first time, the AS paper, like years ago, I had no idea what this question meant. But now, obviously, I've done more maths. I do understand it. So the significance of the magnitude of the vectors being the same is just that they're parallel, because if you think about it, they can't, like, the magnitude of the vectors is equal to the magnitude of both vectors separately. If you do physics, if you think about a vector triangle, this cannot make sense if the vectors aren't parallel, because the location would be the same. The location would be different. And we're saying, so for this next part, modulus. So we have modulus m equals 3. So from O to m, that's just 3, and then m minus n is just the distance from n to n. Like, it doesn't matter if it's nm or mn, because it's magnitude, so it's just the length. And we say that the angle between this vector is 30 degrees, so we can put that out, and then the problem kind of becomes obvious. Whatever it asks here, it's going to be some sort of GCSE trig ratio stuff. Find the angle between the vector m and the vector m minus n, so that's just this angle, so you can just do sine rule. Well, you can do sine rule to find this angle here, and then you can just do 180 minus to find this angle here, and you get that answer. Now, I don't know why they're asking us to do improper integrals at this stage, because this is something you do in the second year, but they kind of want you to think about it. But what you're supposed to do in second year is, obviously I don't expect anyone to be doing this now, because they just want you to think that, like, e to the negative infinity is basically 0, but when you're doing stuff like this, you should create like a dummy variable, so that you can leave the substitution of an infinity to the last second. So basically I've just said t, so it's going from 0 to t, and t approaches negative infinity, because nothing can truly equal negative infinity. And then you compute this, do this, and then you say that this is basically 0. It's a completely minuscule value, so it basically is 0, which means the area is 1. Then it wants you to find, it does say hence actually, so you can't do this normally, like I did, but it's kind of just, you kind of just have to say, because if you think about it, Lun is just, so this is also improper, which basically means the area is infinite. or like it happens at an asymptote, because if you think about e to the x, it never actually hits x equals 0. It never hits y equals 0, which means that this, like, it's kind of like a concept, thinking of from 0 to negative infinity. Same with ln from 1 to 0, because if you think about the ln graph, it never actually touches x equals 0, which means it's kind of a bit weird. But if you think about an inverse function, from what we remember from like a month ago when we did functions, an inverse function is just the original function reflected in the line y equals x, which means that it's going to be the same area because we've reflected the boundaries basically, and we've also reflected the function. So, but remember the area under a curve when it's under x equals 0. Sorry, y equals 0. When it's under y equals 0, the area of a curve is negative, which means that it's just going to be the same as this area, but negative. So it's just going to be negative 1. I definitely should have drawn the graphs out here. That's kind of my bad. But so you just kind of have to think, well, ln x reflection of e to the x in the line y equals x, which means the area, we've just reflected this area in the line y equals x. But obviously the area when it's under y equals 0, then it's going to be negative. So it's just going to be the negative version of that area. What I did here, we haven't actually really like formally learned how to integrate ln x, so don't really worry about what I did here. But anyway, let's move on. So this is also actually no, it's not all section A, because these two questions are also both on the AS paper. So we were just finding gradients here. So the lines are perpendicular, so you can just rearrange this into y equals mx plus c, and then negative reciprocal. You get the gradient. And now we're finding the point of intersection, so you just simultaneous equations. Yep. Next, find using algebra the real solutions to these equations. Well, rearrange, divide by 2, and then you can factorize root. Oh my god, you can factorize root a out. Get a equals 0. Don't divide by root a, because otherwise you're going to mess out a solution. And then you can solve for a at that point. Next, we have this equation. It's a hidden quadratic. It's not very hidden quadratic, but it is a hidden quadratic. So you can factorize this. This isn't going to give you any solutions because it's square root of a negative, or any real solutions. And then you get this answer here. My voice is already going out because of this question up here. Next we have integration. Great. So there's a lot of things you have to do in these like coordinate geometry style integration questions. Firstly, you have to find this point that we're integrating from, so it's 18, and then you can find the area of this triangle. Since this is 3, this is 18. You can find the area, and then now we know where we're integrating from, so we just do this integral minus the triangle to find the area we need, and then it will give us the answer that we want. Next, we got some mechanics. Finally, not finally actually. I prefer to do more pure, but usually they give you a diagram for these sorts of questions, so don't worry about that. But you draw your little cross diagram for the thing. It's actually interesting because you're finding the angle, which they don't usually do. So you have this kind of setup here. You say that r is that. You resolve both ways, and you get your angle. I don't really understand why. Oh, I know the reason why they said that there was another ball hanging is that you had to say that because this is 2g downwards, because it's an equilibrium, the tension also equals 2g, and then you could use that to solve your equations of motion. If you just divide both sides by each other, then you don't even need to resolve this direction. You just need to resolve in this direction, and get sine theta equals a quarter and solve. Next, we got some binomial stuff. I think, one of the first hypothesis tests we found in assignment. So we have this binomial distribution. You do exactly 5 times, so it's just p of x equals 5. Next, we have, it kind of like deconstructs a hypothesis test here. So the hypotheses, I guess that's what you're supposed to say, The null hypothesis is p is equal to 0.4, and then because it says that it's incorrect, it doesn't say greater or less than, so it means that it's a two-tailed test, which means it's not equal to 0.4. It does say that here as well. Then you can use your calculator to find, so you split the significance level into two, and then type it into so you get this distribution up on your calculator, and then on the answer bit you put 0.05 on the lower tail. So this is the lower tail, this is the upper tail. So you do the lower tail first. Well, it doesn't matter which one you do first, but I did the lower tail first. So I found this was the closest, and then because it's above, you check the one below. So you say the critical region is x is less than or equal to 3, which is because that's the region where it's below the significance level, and you do the same thing for the upper tail. So I put 0.05 on the right side, it gave me px is greater than or equal to 12. But then this one is higher, so you increase it by 1 because we're in the upper tail now. So you get the critical region as x is greater than or equal to 13. So this is the two critical regions. And then now we're finding the actual significance level. Well, this is the significance level from the lower tail, and this is the significance level from the upper tail. So you should add them together and put them into a percent. And then the test statistic is the 11 times. So you just say it's not in the critical region because it's not less than 3 or greater than 13. Which means it's fail to you don't say accept the alternative hypothesis, you just say fail to reject the null, because the alternative could still be correct, but we don't have enough evidence to say that right now. So you say fail to reject null, because and then you do a little like exam slop language, so insufficient evidence to suggest that rolling a 6 is not equal to 0.4. You kind of just copy out the question for this last bit. All right. Next we have, did I not do question, wait, I didn't do questions, I was literally thinking in this assignment, I'm not going to accidentally skip a question. This is easy. Write the probability distribution for x. It's just x is distributed, so x little squiggly line, b brackets, 3, 2/3. Yeah, that's literally the easiest question in the entire assignment. I don't know how I missed that out. Anyway, next question. Modulus graph. So you just sketch it out. I think you're supposed to put points in, but I don't care. Next question. Whenever you have f of modulus x, it just reflects. You take the part of the graph that's in the right side and you just reflect it to the left side. And then now you can find the values of a and b because it just tells you this thing here. And then find the value. So now we're saying equal to 5x. You always just want the modulus thing in one side of the equation just because it makes it a lot easier if you can. And you draw the graphs out, you see that it only intersects in the negative side of the modulus graph, so you just make it negative. Remember to distribute the negative as well, so the x minus 1 becomes minus x plus 1, and then you solve. It says the value of x, so you don't need to find the coordinates, you don't need the y coordinate. Alright, this was kind of an annoying question. It's just a bit of quotient rule, so it's useful. It's quite useful to write out your u's, u dashes, v's, v dashes. You do get this in the formula book, so don't worry about it. So vu dash minus uv dash over v squared. And then you do your factorizing and you cancel. The factorizing is kind of the hardest part here because it's a bit weird, but yeah. Because 2x minus 4 is 2 times x minus 2. And then, yeah. And then the x minus 3 comes, so you factorize 2e to the 2x out. You factorize x minus 2 out, and you're just left with x minus 2 minus 1, and you get that. And then you cancel your x minus 2 out. Oh, I didn't. That's supposed to be a 3, not a 4. Finding the equation and tangent, well, it's actually quite annoying here because you have to leave this in exact form. So you should always try and leave an exact form when you can. So you say that you substitute 1 into the dy by dx to get the gradient, and then and you also substitute it into the main equation to get your y coordinate, and then you do y minus y1 equals mx minus x1, and then rearrange whatever, get your answer. Alright, we got some trig now. Oh god, these last few questions were so annoying. So firstly for this question, you can turn sec squared minus 1 into tan squared, and you just solve it like a hidden quadratic. Kind of just going to quick fire these. This question, you expand, get sine x equals 0, from you take away 3 sine x from both sides, factorize out. Remember, never divide by variable. And then especially because if you did divide by a variable, you would get cos x equals 3/2 as your only solution, which doesn't actually give you any solutions. Part C, you can turn this into, you can just actually expand all of this and it works. I turn cos 2x into 1 minus 2 sine squared. And then you can remember the plus or minus when you're square rooting, and then you get your answers. Yeah, just expand this. Don't divide by cos, factorize cos, get sine, and get your sine value, and then you can solve. And then for this last question, this is something you can do in FP1, but it's really not that complicated here. You just let t equal tan theta, and in this question it's completely trivial because everything is in terms of tan, but it's just an easier way, so I don't have to write tan theta every single time. So I just you get t equals 0, and then t would be equal plus or minus I, but that's obviously a complex solution, so because we have t cubed plus t equals 0, so you only have t equals 0, and then you solve tan theta equals 0. Right. Next question. Yeah, I just wrote this partial fraction stuff. I mean, there's nothing really that interesting about it. Multiply out, get your simultaneous equations, and then write it out. Same thing here, write it out, multiply by all the denominators, or multiply by the full denominator of this. That's how you know what to multiply by. Get your simultaneous equations and write it out. Same thing here, write it, multiply by the denominators, get your simultaneous equations. I didn't actually expand these out, but you should. I mean, just for simplicity, you should probably, and making it easier to read yourself, you should probably expand this stuff out. You can kind of just tell by multiplying out in your head. So you get your equations, and then these are a bit more annoying to solve, but it worked out in the end. And then you write them down. Alright, great, another hypothesis test. Well, here it's saying that it's a less than, it's saying that is it lower than this? It's a lower tail test. You do hypotheses. Part B, you actually do the hypothesis test. Remember, set out your variable, set out your distribution. Always do p-value when you can. Oh my god, always do p-value when you can. It's so much easier. Do your thing. Do your little rejection statement, or not rejection, just your statement. And then that's your hypothesis test done. I think this question's come from a previous assignment before. It sucks. It's just annoying. You find the stuff that it asks you to. So this is f-1, this is g-1, and this is gf. Then, I mean, you just do it. You multiply this. Yeah, you just multiply. And yeah, that's literally it. Multiply the functions, and then you get it, and then this one you have to inverse the entire thing. So you do that, and then yeah, that's literally it. You just show they're equal to each other. Sorry, I'm just kind of zoning out. This question's a bit annoying. All right, so these two, proving these identities is a lot harder than you would think it is. So in the learning pack, there is a weird example, but I don't really know how it works. And this is the example I learned, and this is one in the textbook, so I'm just going to use it. So you get this square here. You say that this angle is beta, and this angle is alpha minus beta. This entire angle is alpha. And the only information that you give yourself is that this distance is 1. And obviously these are all right angles. And then you could say that this angle must be alpha, this angle must be alpha by parallel, or by you could just kind of deduce it. And then you say this side length is cos beta, how did I, wait, what am I doing? Sorry. Yeah, sorry, yeah, this is a right angle triangle here. So this thing is a right angle triangle. You say this is cos beta, this is sine beta. And then this is sine alpha minus beta, and this is cos alpha minus beta. And then now we can say that because now we have another right angle triangle, this is sine beta, which is the side length, times cos alpha. This side length here is sine alpha sine beta. And then you can do the same thing with this triangle. We say this is cos alpha cos beta, because the hypotenuse is cos beta, and it's obviously adjacent equals hypotenuse times cos alpha. Same thing you do here. So this is sine alpha cos beta, and then when you have this entire square set up, you can just say, well, this side equals this side, and this side equals this side. So because it's a square, and then you can prove the identities. Well, for this one actually, because this proves that a minus b or alpha minus beta ones, but you can just replace beta with minus beta, and with both of them, and you can say that these are the results you need to remember. I don't know if they formally teach you these, but they're in the syllabus. So so cos beta, cos x is an even function, so cos negative x just equals cos x, and then sine is an odd function, so sine of negative x is negative sine x, and then you do your you can simplify this, and then you get your identities. Pretty complicated proof. I would definitely look in the textbook. It's in the chapter. It's in the Pure 2 textbook. The chapter is called Trigonometry and Modelling. So you can look at that if you want. I don't really understand what they wanted us to do for these proofs. I kind of just set them out as improving the double angle formulae. So yeah, you said this is cos x plus x, and then you just basically do what you would usually do but longer, because I'm not really sure how much detail they want you to go in. But yeah, then next we have some annoying differentiation stuff to do. So differentiate the left term. Normally differentiate the right term, you have to do some implicit differentiation, and then you have to do some product rule and implicit differentiation for the right term, and then you can rearrange. Next, that literally just tells us, it just completely moves on to a different question. So you do the same thing, differentiate both sides, and I factorize the 2 out because I know that this is going to turn into 0, so the 2's are going to become irrelevant. And constants don't mean anything. Constant terms, and whether they're multiplying or dividing, don't do anything. So you can just factorize them out when you're differentiating. So do some product rule and implicit, and then rearrange the dy by dx, and use some of your sine over cos identities. Next, with showing that this is the tangent at this point is y equals 3x. Well, we know the point, so we just need to find the gradient now. And we have the derivative, so we just put in our point. It just becomes tan of 3 times pi over 12 times tan of pi over 4, so it's just tan squared of pi over 4, which is 3, because tan squared of pi over 4 is 1. And then you can use y1 as y1 equals mx minus x1, and you get your line. Alright, next, the best question on the entire assignment. So this is a ridiculous question. I don't think anything like this would ever come up. Hopefully, we pray. So obviously this is called bearing. I think this is the only thing you actually need to know with part A. So this first one's kind of simple. This is just, this is kind of simple. This is just west. This is southeast. I drew a little graph out here for the northeast, southwest, and obviously this is southwest. So each one is 90 degrees, and obviously if you want to go southeast, so you would be 90 degrees plus 45 degrees. So this would be southeast. This would be southwest because you're adding 45 degrees onto south. This would be south-southwest because half of 45 is 22.5. So we're adding half of a change onto this. So we're in between here. We're here. So this is so it's southwest but more south. So just south-southwest. Now this one, this is just 45 added to set. But what this should be right? So this is just in like the kind of direction of northwest, and this is in the kind of direction of northeast, because you can kind of just look at it here. So if it's anywhere like, if it's obviously it's in the middle, and if it's in a 22.5 range of the middle, then it's just northwest or like whatever. But if it's outside that 22.5 range, then it would be northwest or northwest west, I guess. Geez, the stuff I do to for the large data set, honestly. So then this question, so the reason I'm explaining all this is because of this next question. So smallest bearing that would give a cardinal direction of just east is actually dividing, because we're saying that if it's 45, then it's northeast. If we take away half of 45, so it's 45 plus 22.5, that would be northeast east. But if we had another half, that would be to east to even classify it as north. So if it's more than, or if it's 90/8 degrees away, so 22.5 divided by 2, so if it's 12.25 degrees away from a direction, then we just don't count the other direction that it's in, so we just say it's east. So the smallest bearing that would give a direction of that is 90, because that's east, minus 90/8, which is this. And you have to, I don't, in the answers they didn't do this, because you did have to do this at GCSE, and I'm not sure if you still have to do it now. But for bearings, you usually have to round, and they also have to be in three, what's the name? They have to be in three thingies. They have to be three significant figures. And another note about bearings, they always start from the north. Remember, that's why I did a highlight of the north. Usually when you're on graphs, like when we do polar coordinates in year 2, theta usually starts from east and goes this way. But when you're doing bearings, it starts from north and goes right for some reason. I don't really know why. But anyway, so the first two aren't too bad. So for southeast, it's just south, or the middle of, like, the boundary of southeast is here. So if we just add on, wait, southeast, wait, I didn't even get that. Wait, how is that? Sorry, I don't know what's got on here. Oh yeah, no, sorry. So the smallest bearing that goes southeast. So we take 90. Obviously, if it's only 2 away, then it would be south or southeast east. So it has to be in away from this 45 degrees. It needs to be 12.25 degrees to the left or right of this, which means, but obviously we're looking for the smallest bearing, so we're just going to do 12.5 degrees this way, or 12.25 this way. So you just do 90 plus 24.5 plus 12.25, and you get that. Now this is where it gets a bit annoying. So northwest, if we're looking at this now, so this is like this, and northwest is just, that's very close to 360. So it's just 360 minus what we just did before, minus 3 times 12.25, which are like this tiny increments that we say. And then for east, it's not southeast east, it's actually east southeast for this last one. So, and for east southeast, which I was explaining earlier, you only do 1 increment of 12.25 instead of 3, because if you did 3, it would go to southeast, but with 1 in the range of 90 plus 1 increment to 90 plus 3 increments, that is east southeast. Which, so the smallest would just be 90 plus 12.25. Yeah. So if you didn't understand a single word of what I just said, don't worry, because if this comes up, then no one's getting marks on it. And you don't have to do it next year. Even if you do further stats, there's no large data set, thank God. So yeah, thanks for watching. I'll see you guys next week. Yeah.